Hey guys, welcome to our Ephysics class. So our topic for today is impulse and momentum. So the first one, when we talk about momentum, what we call linear momentum and translational momentum or simply momentum. It is the product of a body's mass and its velocity, where your P is the momentum, your M is equivalent to your mass, and V is the velocity. Momentum can be thought of as the power when a body is moving, meaning how much force it can have on another body. So it's like when you have your momentum, like in studying, when someone disturbs you, there is this change in your momentum while doing something. Momentum is mass in motion, and any moving object can have this what we call momentum. It is inertia in motion. So that's a brief definition of your momentum. So for your momentum, we define the formula. So that is P is equal to your mass multiplied by your volume. So first, it is a vector quantity. So it has a direction, and of course it has a unit. So velocity and momentum vectors point in the same direction. Of course, there's a velocity across that direction. We also have that momentum in that direction also. For the SI unit for momentum, that's kilogram mass per second, and a net force is required to change a body's momentum. So momentum is directly proportional to both mass and your speed. Okay? So something big and slow could have the same momentum of something small and fast, because the impact of a very large mass moving slowly will give the same impact of a very small object but moving fast. So it's like comparing it to a bullet, and of course comparing it to a hollow blocks moving slowly with a bullet moving so fast. Impulse is the change of momentum of an object when the object is acted upon by a force for an interval of time. So with impulse, you can calculate the change in momentum, or you can use impulse to calculate the average impact force of a given collision. So here's an example. So there's an impact. Now we're talking about the impact. That's why the words from the impulse and the impact. So there's something about in relation to that. An impulse is equal to the net force on the object times the time period over which this force is applied. So forces applied over time periods create impulses. So if your forces changes over time, okay, so the impulse changes too. Impulse is measured in Newton seconds, and that change in momentum is measured in kilogram meter per second. Pronounced kilogram meter per second. So the unit is the same, okay, although some are using Newton seconds for impulse and kilogram meter per second for our momentum. So to avoid the confusion, although using the same units can also apply any of the units applied above. So our given forces, force equals mass times the given acceleration. So remember that our acceleration is equal to the change of your velocity divided by the change of your time. Cross multiplying the equation, we will get the force multiplied by the change in time is equal to your mass multiplied by the change of your velocity. So for impulse and momentum units, to clarify the usage of units, first remember that mass units are kilograms. So we will use kilograms for our problems, and that acceleration units are meter per second squared. For the given kilogram, that's a unit for mass, and that is a unit for kg. So for your meter per second squared, that is unit for acceleration, is also equal to your meters per second squared. So these are the units that we usually use from our previous problems. Like in Newton's law, remember that a Newton is a kilogram meter per second squared. So our Newton is a unit for force, that is force is equal to your mass multiplied by your acceleration. And your Newton is equal to kilogram meters per second squared. So when you simplify, you will get this one. And your Newton, given that unit, when you expand, you will get kilogram meter divided by S multiplied by your S, which is also equal to your S squared. So from the given diagram, it will show you that the impulse unit Newton second is also equivalent to your momentum unit, which is kilogram meters per second. So kilogram Newton is equal to kilogram meters per second squared multiplied by the given s from the given unit of our momentum is also kilogram meters per second. So we will just cancel s here and we'll get both kilogram meters per second. So usually if one is discussing momentum or changes in momentum, one uses the kilogram meter per second unit. If impulse is under discussion, so then Newton second is commonly used. However, guys, there is really nothing wrong with interchanging the use of these units. So let's take a look at a simple problem. This is a basic impulse problem. First is, imagine that a force of 2 Newton is applied to an object for 3 seconds. So here is how to calculate that impulse. So for our given impulse, that is your force multiplied by the change of your time. Okay. So your impulse now, given that you have a 2 Newton force, multiplied by your 3 seconds change, that's from 0 to 3 seconds. So you will get 6 Newton seconds.